Right. So the first one is the first thing. We learned it a couple days ago, but I'm kind of struggling with it. So it's transformations
Okay.
of the step graphs or piecewise functions or whatever you call them.
Okay.
You know. Yeah. So it just wants to sketch a function and provide domain and range. So I was hoping we could do a couple just to kind of get the feel of it.
Okay.
All right. So the first problem I have says 2 and then x in brackets.
When you say brackets, like that?
Yeah, like that.
Okay.
And then plus 3.
And these brackets mean the greatest integer function?
Yes.
So really they are like this, I think. Or not.
Yeah, something like that.
They're not closed at both ends?
They are.
They are closed? Okay. It still means the greatest integer. In other words, if x was 3.1, then this would be 3, right?
Mm-hmm.
Okay. So if we graph the elementary function goes basically like this, and it's closed, let's see, that would be 1, 2, 3, and it's closed on the left end and open on the right. Am I correct?
Mm-hmm.
Okay. So this has two things going on with it. It has, what's the consequences of that?
That shifts it up.
Right.
The y value up.
Right. In other words, it doesn't change the shape of the curve, it just moves everything up 3 units. So hold on, if I label this axis, then let's do these one at a time. Let me use blue. So if I do just the plus 3, then I would go up 3 units and I would have with me?
Mm-hmm.
So that would be greatest integer of x plus 3. Now, what's the consequences of that 2?
Does it shift it,
So,
it gives it space between the two
the
steps.
vertical stretch. So that every point that you see on this curve would be twice as high. Let me see if I can put enough scale on this thing. So if I go up to 5, 6, 7, 8, then this part right there is going to go from there to there. This part right here is going to go up from 8 over and so forth. Now, let's check and make sure that that's the right graph. If x were 5.5, and now let's use a number between 0 and 3. If x were 2.5, let's put that in this area here, we should be 7. Oh gosh, hold on a moment. What am I doing wrong here? Interesting. Let's go back and do this from the start. I didn't realize that it mattered which one of these you do first. It appears to. Here. There's our greatest integer function. If we multiply it by 2 first, then all it does is vertically stretch it. Let me use the blue pen. And it vertically stretches it by a factor of 2, so there would be the first one. There would be the second one. And this would be the third one. In other words, my blue is 2 times the greatest integer function. And if we check just this part of it, if x were 2.5, we should be at 4. And we are. We're in this range right there, right? In other words, whenever x is between 2 and 3, then y is 4. So now we want to take the blues and shift each one of them up 3 units. And I'll draw that in green. The only thing is when I use green I can never see it. I'll use red again. So this blue here gets shifted up 3 units to right there. This blue here gets shifted up 3 units to right there. And this blue goes up to right there. So let me erase everything else, and now let's check to make sure this is correct. If x were 1/2, we should be at 3, and we are. If x were 1.5, we should be at 5, and we are, and same thing if x is between 2 and 3. So, interesting. Was not aware of a translation of this function having it matter whether you shifted it first or vertically stretched it first. But it definitely seems to, doesn't it? In other words,
so stretch first,
yeah, you got to do the vertical stretch first and then the shift.
Okay.
Okay. What else?
Okay.
What else do you have?
Cool.
Before I erase that.
I have another one.
Is it a greatest integer function also?
Yes. So this one says negative, and then the little bracket thingies, 3x. Yeah, close them, the little bracket thing. Yeah, and then plus 1.
Alright, so on this one it should not matter which we do. Well, you always want to do your reflections first.
Okay.
No matter what you're dealing with, whether you're dealing with greatest integer function or any polynomial or a sinusoid function, you do your reflections before you do anything else. So if I were to take that original greatest integer function and reflect it over which axis?
The y-axis?
The x-axis, because the negative sign is outside of the function.
Okay.
Okay? If the negative sign was inside the function, in other words, here's the thing that you want to understand. If our function is that, what we are looking at is negative f of x plus 1. The fact that the negative sign is in front of the f of x means it's a reflection over the x-axis. If it was f of negative x, like that, then the negative sign would go inside the function. And that would be a reflection over the y-axis. So f of negative x is reflection over the y-axis, and think of it as even and odd functions, kind of. When you have the negative sign inside, it's an even function. It's a reflection over the y-axis. When it's outside, it's a reflection over the x. So, let's see here. The first thing we would do, if we do it step by step, would be that, I believe. In other words, what I've drawn here, if I take away those, would be just y equals negative greatest integer function. And let's see if that makes sense. If x were 2.5, then we know y would be minus 2. And that's the way I've drawn it here. Okay? In other words, you can always check these by plugging in numbers. In other words, the one I've drawn is this. And like I said, if I test 2.5, well, the greatest integer of 2.5 is 2. Throw in the negative sign. It's negative 2. That puts it in that range right there. So we've done the reflection properly. Now, I don't think at this point it matters whether we apply the 3 or add the 1 first. The 3 acts as what? How would I describe it? That's incidentally the same as putting a 3 inside like that. It's f of some constant times x.
Oh, okay. So, would it stretch it horizontally?
It's a scrunch, actually. When you are stretching vertically, a number greater than 1 is a stretch, a number between 0 and 1 is a scrunch. When you are stretching it horizontally, a number greater than 1 is a scrunch. A number less between 0 and 1 is a stretch. Okay? So if I now want to plot, I want to stick the 3 in like that and try to plot this in blue. It would scrunch everything up so that the first part would go from there to there. The next part would go from here to there. And the third part would go from there to there. Okay? And let's see if that makes sense. If x is 1, I should be at negative 3. And I'm not. So let's see. I got to do a bunch of stuff to this. I can see why you were confused by this. Doing transformations of the greatest integer function is a little tricky. I can remember running into this in the past and forgetting that it's a little tricky. Let me think for a second. If x were 1, we need to be at minus 3. If x were 1/3, we need to be at minus 1. Okay, so this thing draws like this. Let's see, from 0 to 3, we're going to be here. Or from 0 to 1/3. From 1/3 to 2/3, we're going to be here. And from 2/3 to 1, we're going to be there. Now that should reflect that. If we plug in some numbers, I believe it does. Does it not? Let's see. If we plug in 3/4, then that would be 9/4, 2 1/4, 2 minus 2. So the blue graph that I've drawn reflects this. Okay? Now, to add 1 to it, clearly adding 1 to the back of this merely means moving each of these up by 1. So, if I draw it in black, I've got I am not having a good day today. Let me not draw it in black. Draw it in red. And finally, the third one would be like that. Okay? So that should reflect our function. And now let's try some random points just to make sure. If I plug in the same 3/4, then obviously that's minus 2 plus 1. We should be at the minus 1 place, and I am. If I plug in a number in the middle third, like a half, then that's 3/2, greatest integer, which is 1, and I should be on the 0 place. So I am. So that's my correct graph. Trying to figure out how to think about this without having to plug in numbers to figure out where it is. In other words, when you put a number inside the greatest integer function, it does have the effect of horizontally scrunching it, but in a kind of a strange way. In other words, it took all three of them that I had going from 0 to 3, and it scrunched everything down to 0 to 1. Which I guess is a similar thing if you were to take a sine curve and apply a horizontal scrunch. it would do that. In essence, that's what we've done to the greatest integer function here. Yeah, in other words, when we scrunch a sine curve, it goes from 0 to 2 pi to begin with, and after we scrunch it down, it goes from 0 to pi. Well, the greatest integer function is similar in that it originally went from 0 to 3, the first 3 legs of it, and now those first 3 legs all happen between 0 and 1. So you can kind of think of it in the same way as thinking of a sinusoid function.
Okay.
Same with a vertical stretch, whereas if I was going to do a vertical stretch on the sinusoid function, I would do that. The greatest integer function does a similar thing. Just stretches them out. Okay? What else you got?
Okay. Like one last thing that I just want to go over.
Uh-huh.
Probably simple. Okay. So it wants to solve the following.
Okay.
And it says that INTX intersection? I don't really know what that means.
That's probably greatest integer function. Like that?
Okay, cool.
With the brackets?
Without the brackets. Just INTX.
Okay. I think that means the same thing. I can't imagine what else that would mean. Go ahead.
Okay, equals log of the absolute value of negative x plus 4 plus 3. And then I just don't know how to solve this, like, at all. My teacher wasn't here today, but we still have homework, so I don't really know what this is. So. Do you graph it and then look for, like, an intercept? Or?
Well, I'm not sure what this means.
Me neither. Nobody in my class knew today, and our sub wasn't a math teacher.
Well, I got a feeling this is a problem of just how to do this translation. In other words, how do we graph that? And it's not completely trivial how we graph this. So let's go through how to do this translation. Oh. Got alarms going off that shouldn't be going off. Log of x. In other words, if we say this is, well, let's go back. If we say f of x equals log of x, let's talk about that. Log of absolute value of x. Wow. They're really going to make it tough. Well, first of all, the log of x looks like this.
Okay.
What's the log of absolute value of x look like?
I don't know. The absolute value is a v. I don't know about the log, though.
Well, if I said f of, or if I said the log of absolute value of x that's going to act as a reflection like this, I believe. Let's think about that for a second. First of all, x can't be 0.
Yeah.
Even for the absolute value of x, it can't be 0. It can now, however, be negative. In other words, if I talk about the log of x, the domain is x has to be greater than or equal to 0. But if I talk about the absolute or the log of the absolute value of x, now x can be plus or minus.
Okay.
Which means the log of the absolute value of -1 is 0. The log of 2, in other words, that's 1. That's 2. This has to be -1, -2. So the log of the absolute value of -2 is going to be the same as the log of 2. So this graph is this function right here. Now, the +3 part is pretty easy. We move everything up 3. What's inside the absolute value is a little tricky. We've got a +4, which is a horizontal shift. So let's see if we can graph just this part of it. Blue.
Okay. So like up and over.
In fact, let's do something else. Let's see what the graph... Here's what I'm thinking we have to do here. We have to actually write this a little different. Now, if we write it this way, now we have two things going on inside the absolute value. We have the negative sign and we have a horizontal shift. The horizontal shift goes to the right by 4 units. The negative sign reflects over the y-axis.
Okay.
A reflection over the y-axis doesn't change this thing very much. In other words, if I were to graph the log of absolute value of -x like that, I would get this graph in red. Same thing. Right?
Yeah.
Because if I reflect that red graph over the y-axis, it doesn't change. It's kind of like reflecting y = x squared. You reflect that parabola over the y-axis and it looks exactly the same. So the consequence of this negative sign doesn't do a lot if it's just in front of the x combined with the absolute value. However, we have a horizontal shift here. Then we're going to reflect over the x-axis. So you always do your reflections first. So let's reflect and then shift. The question is, do we shift to the right or the left? I think we shift to the right. So we're going to have a new asymptote at 4 instead of 0. We can test this. So let's see. If I'm correct, this thing should look something like this. Hold on. Let me draw that left part a little better. That was pretty pathetic. Okay, so I'm saying that the graph of that part of it is this graph here. Well, if x were 4, we could not take that. In other words, we need a vertical asymptote at x equal 4. We have it. But now, if x is 5, now we're taking the log of -1, which means we're taking the log of 1, and we would be on this point right here. So that would be correct. And if x were 3, now we have -1, so we're taking the log of 1 again, and we would be right there. Okay, so we've satisfied those points. Now let's see, if x is 6, then we would have the log of 2, which is going to be higher up. And if x were 2, it would be 2 minus 4 minus 2, 2. We'd still have the log of 2, only it would be, it would be there also. So the translation to the right was correct, even though it appears that this is going to be a translation to the left. What you have to do is convert that to this in order to follow the standard rules of translation. And of course, then to get the +3, we take this blue graph here, move it up 3 units, and you end up with something that looks like that and like that. Okay? Yeah, on all of these, the secret is in testing it after you've graphed it. Make sure that when you plug in some points that it's relatively easy to figure out what y should be, that you're in the right spot. Okay? All right, Sarah. Sorry I went over a little bit on you.
Oh, no problem. Thank you.
Okay. Talk to you next time.
All right.
Bye-bye.